Let's use the second derivative to discuss the concavity or the curvature of a function. F of x is x cubed minus 6x squared plus 9x minus 1. So let's find the second derivative. The first derivative will be 3x squared minus 12x plus 9. The second derivative will then be 6x minus 12. So my second derivative, whether or not that's positive or negative, tells me the curvature, whether or not I'm concave up or concave down. And the only way that a function, in this case, the second derivative, can change sign from positive to negative is by the intermediate value theorem, zeros or discontinuities. So the second derivative is a straight line. It's always going to exist. It's continuous everywhere. So let's figure out when is it going to return a 0. So that occurs at the x value of 2. Now let's see if it actually does. Let's construct a sign chart and look at the value x is equal to 2 and give ourselves test points in each of these intervals and see what that implies, or see what the value of the second derivative implies about the original function. So if you plug in 0 into your second derivative, you would get a minus 12. So it's negative. It's the second derivative. So I like to say that it has two negatives there. What does that mean about the original function? It's concave down, right? It kind of looks like a frowny face. If you plug in 3 into the second derivative, this returns 6. That's greater than 0. This is positive, positive, because it's the second derivative. That means the function is concave up, kind of makes a smiley face. All right, so our function is concave down until 2, and then it switches. So we have what's known as a point of inflection right there to concave up, right? That looks like a cubic function.